Welcome to learn Advanced Bash for System Automation and Productivity Boost. The primary objective of this course is to help you automate your daily system tasks and engineering processes with Bash scripting to boost productivity. This course will focus on Ubuntu Linux, one of the most popular Linux distributions. The techniques you learn to create and configure virtual machines in this course can be used to set up any other Linux distribution for developing your automation scripts for larger teams and projects. You will learn the expertise from many years of successful bash scripting in Silicon Valley high-tech corporation. Why do we learn bash? Let's see the power of bash. Bash is a de facto standard scripting language on Linux, Mac OS X, and Unix. These days, Bash even works natively on Windows 10, and for all versions of Windows, Bash works in hybrid mode in Sigwin, JigBash, MinGW, M62, etc. The Bash scripting skill you learn in this course can be applied to automate your daily system tasks on Linux, Mac OS X, Unix, and Windows. Those are the compelling reasons for us to learn Bash. What will you learn in this course? You will create and configure virtual machine via Oracle VM VirtualBox on Windows. You install and configure Ubuntu Linux 16.04 LTS for long-term support. You learn advanced Bash scripting from scratch. You learn the basics of Linux file system and commands. You practice your Bash scripting knowledge on Ubuntu Linux. You learn solving problems with divide and conquer technique in Bash scripting. You learn developing menu-driven and option-driven Bash scripts. You learn techniques to excel automation and boost productivity via Bash. In particular, the Bash feature you learn in this course will be shell expansions, decision and looping constructs, function and nested function, string and arrays, regular expressions, I/O redirection and process substitutions, command line options, system signals for inter-process communications, built-in and environmental variables. Finally, last but not least, debugging techniques. In the next session, we will set up Ubuntu Linux for our labs so you could practice your Bash scripting knowledge to turn it into skill. See you there. Welcome to Session 3, the basics of Bash scripting. In this lecture, we have a short introduction about Bash. Bash stands for Bound Against Shell, BASH. A Bash script should begin with the following line: /bin/bash. The pause and exclamation point here are pronounced shebang. Again, /bin/bash should be the first line in a Bash shell script. On the third item, a simple Bash example. It demonstrates. Here, the first line is again /bin/bash and then echo hello bash. So what it is that it will print out the hello bash on the console. The first line /bin/bash is to have the system load the bash interpreter at the directory /bin, and the application, the binary for the bash interpreter is bash in lowercase. In lecture 3.2, we learn about the difference between double and single quote in Bash. Double and single quote have a subtle different look but very important meaning in Bash scripting. For example, when we store the value 2 into the counter variable, then we echo double quote $counter closing double quote. This will print 2 on the console. However, if we write in our script echo single quote $counter single quote, the text $counter will be printed on the console. Why is that? The reason are because of the variable expansion in bash. In double quote, bash interpreter will expand this variable and take the content inside the counter, which is the string number 2, and then displayed on the console. With a single quote, the bash interpreter will not expand to take the content of the counter variable. Instead, the bash interpreter will print out exactly the text as is. Let us go to the lab and try out what we have learned so far. See you in the lab. Welcome back to the lab. Just like many other languages, we will begin our bash scripting with the hello bash. Let's click on the window and cd without any parameter to go to the home directory. And here we will make our new directory. mkdir make the learn advanced bash. Okay, so we will make this directory, and after we make that directory, we'll cd into it. We change our directory into lab, into lab. Okay, here we are in the lecture 1 of session 3, so we will make a directory minus p and then 3.1 n. So I will work on the end, and when you practice in the lab, you are recommended to follow the example, follow the lab, and try it out for yourself. So you will do it in the start. Here we work it out together, and we do it in the end directory. So know that the make the -p will make multiple subdirectory. Otherwise, we have to make the 3-1 and then make the again with 3.1/n. With the -p, we can do both at the same time. Okay, and we will cd to that newly created directory, and we do cd. Okay, there will be a lot more to learn later in this course, but here I'm showing you a quick shortcut right here. If you hold out the left on key and then the period, the dot on together, then the last argument of the previous command will be retrieved. Okay, so here the name of the newly created directory is retrieved, and we can cd into that directory without typing it. Okay, so now we are in the lab 3.1 and directory. If we want to make a start directory at the same level as the end directory, we can do make the ... go back to the parent directory. That means that 3.1, and then say start. So this is where you will do your work to practice later. Okay, so when you say ls ... we will display the listing of the parent directory. So you can see that we have both the end and start, right? So we are in the end. Okay, so we have a structure for our lab now. Let's begin our first script. We will start subl sublime, and then we say hello bash. Okay, the .sh is extension for the shell. Most of the shell we have a .sh. Hit enter, and then now we are here in the hello bash file. We can begin typing /bin/bin/bash. The pound sign and exclamation point is a directive to indicate where the system can find the bash interpreter. Enter, and then we say echo hello bash. Okay, and let's hit Control S to save it. Here we do the ls, but this ls only shows the hello bash, right? To see more detail of the file, we say ls minus l, that for a detailed version, and we can see that here it rewrite for you, the user it rewrite, for the group it rewrite, and for the word it read only. So people in the same trainer group can modify this file, but people out there not in the same group can only read it, cannot modify it. And this one is called 664. Okay, so here it 1, 2, 4. So 2 and 4 are 6. So 6, 6, and this is 4. Okay, and we must have the executable privilege in order to execute this file. So to add the executable privilege into this file, we do smart m chmod and u+x for the user add the executable, and then we will do it for all file in this directory. Now we do the ls minus l again. We can see that the executable bit is now added into the file privilege, and the file name turned to green. It's no longer white like before. Okay? It is green now. And here, to execute this file, we must say dot for the current directory. This is where to find the file, /h, and then hit tab key. Okay? This tab key will auto-complete the file name, and you don't need to type the whole file name. Alright, hit enter here, and say hello bash. So the echo command is the way to print out the message on the console. This is the console, and we just display the message hello bash, and we just got it. Okay, and that is for the first video. Let's pause the video here, and we will try our second bash script in the next video. See you then. Welcome back to the lab. In this video, we will try the second example of session 3.1. And before, we will try SU sublime show value. We will begin to type here /bin /bash, and then we define a counter variable, and we store the value of 2 into that counter variable, and it's an echo counter, and then echo, but this time we use a single quote, not double quote like the line above it. And save the file. Now go into our terminal, we say ls minus l. We can see that one is green and the other one is white, and we know the reason why they have different color, right? Because here the executable bit is not set in the second file. Okay, so to set that executable bit for the user, we use the command smart u+x star for all file. Now we say ls minus l. They both have a green color, and they both have the executable bit set for the user. Now we can execute the show value.sh. Like before, we hit tab, and we got the entire file name displayed. Hit enter, and you can see that 2, the value 2 right here, it came from a double quote, echo double quote $counter, print out the value of 2, because it is the variable expansion. The expansion only happened within a double quote. For the single quote in line number 4, the echo will print exactly what it is inside the single quote without any variable expansion. As a result, the dollar counter is printed here. As is, no expansion for this variable. This example shows the subtle difference but very important difference between double quote and single quote in bash scripting. And that is for our lab. I'll see you back in the lecture. In this lecture, we will study variable expansion. Variable expansion we have encountered in the earlier lecture. It is here again for completion. From this example, we store a string 8 into the variable count and then we echo the content of the variable count on the console. Note that the braces around the count variable are optional. However, if there is another letter that immediately follows the count variable, then the brace becomes mandatory. The reason is because without the brace, this count will become count with another T and H follow it. As a result, the bash interpreter will not be able to identify or to locate the count th variable. Hence, the braces are required in this case. Let us go to the lab and try out what we learned in this lecture. Welcome to the lab for lecture number 2 of section 4. Just like before, we need to go on the way to the lab directory. We can do ... to go to grandparent directory like before. Okay, and here we can say make the -p for that 2/n and cd on dot to go into that directory. And we can also close the example of the previous lecture. Now we create a new one. In this one, we will edit a file called variable expansion. Variable expansion has been discussed in the previous section, but it is here again for completion. So we begin our usual directory /bin/bin/bash, and we also assign a value to a variable. So let's say we assign 8 to count, and then we print echo $count. And this time the echo doesn't have to have the double quote. The double quote is optional. It can be omitted. The single quote is required to keep everything the same, but the echo will be when you print something, it can be optional, right? The printf, because the parameter in there, it need to be formatted, they need to group together. So printf, we learned in the previous lab, printf have the double quote, but echo, the double quote is optional. Okay, and on the next slide, we also say echo $cow. But this time, cow is surrounded by open and closed braces. Okay, so open and closed braces are both optional. They don't have to be used. However, if there is another letter following the cow, like 8, like if we say echo 8 floor, right? So we select it. Now, because of the word th immediately follow the variable count, we need the braces to separate the variable from the letter to tell the bash interpreter there are two different ones. Right? So now we save the file and we come into our terminal, click on it to get a focus, and we do our usual command smart u plus x star, and then now dot, because this is the first one in the folder, we just tap and we have, as you can see, the 8 and the 8th floor are printed. In the second echo, without the brace, then the count with the TS follow immediately cannot be recognized by BAS. So we have to separate them like that. And that's what the point for this lab. Okay, let's pause this video here and come back in the next video to learn more about the brace expansion. Welcome to lecture 4.3 brace expansion. In this first example, we run echo T brace, and then we have A, O, I between the braces, and then we have a letter M follow the braces. This brace expansion, when it expands, the echo command will print out temp, Tom, team on the console. So the brace expansion will expand these three letters 3 different times with the data that preceding and following the braces. Brace expansion are very handy. We use it to copy data from one location to another. For example, if we need to copy data with the CB command, the sort the destination like this, we notice that the destination only have the underscore BK extra to the original file name. Therefore, we can save some typing by issue the command CB space data and comma underscore BK between the braces here. When BAS interpreter apply brace expansion, it will become two words data.text and data underscore BK.text as if this command. Similarly, when we move the file between two different locations, we issue the command mv and then the file name and another file name. Here, because the two file names reside in the same directory, this move command will actually a rename operation. It will change the name code to O dash code, and we notice that the two names only different in the O dash at the beginning of the name. So we will take advantage of the brace expansion to save us some typing. We will do the command open brace, comma, O dash close brace and code. This will expand nothing here and then code and then space, and after that O dash code, as if the command is typed like this on the right side. Furthermore, brace expansion can be utilized to get a sequence of number or letter, and that sequence will be consecutive. For example, if we issue the command echo brace 3.6 closing brace, the consecutive sequence number 3, 4, 5, 6 will be displayed on the console. Similarly, if we issue echo brace b d brace, the sequence b, c, d will be displayed on the console. This is the end of lecture 4.3. Let's go to the lab and try out what we just learned in this lecture. See you there. Hello and welcome back to the lab. In this lab, we will try out the brace expansion that we just learned in the lecture. Okay, so now let's go back out to the grandparent directory and make another directory for our 4.3 lab. Okay, and before we go ... and now we do the make there -p for that 3/end, right? And then we do the cd with the on dot to go to the newly created directory. And here, let us close out the example for previous lab. Okay, so now we are going to edit a new file. Okay, so Support brace expansion. Okay, so as usual we do shebang, slash bin, slash bash. Okay, and here we would do echo t slash a slash o, and then I, and then right place to close it, and then M. Okay, so here we do Control S to save it. Okay, and before we do smart U plus S star, right? And at this point, rather than do smart U plus S star every time, let us define another alias for ourselves. So we would go here, say Control A. So this is a very popular shortcut library that we have in the Bash shell, and we practice along the way. So I'm sharing with you Relay shortcut. They are standard library. They are available on the Bash shell. It's good for us to practice along the way so that we get used to it. At the same time, toward the end of the course, we have a tip for productivity, and we put out the dozen of the shortcut that we use every day. And here I'm sharing with you along the way so that we can practice. Okay, Control E, go to the end of the line just like we were before at the end of the typing. Now we go back to the beginning. Control A, I will say alias equal alias mkx for make executable bit, right? We enable the executable bit, so we can mkx, and we say single quote. We Control E to go to the end, and we put another single quote, right? So hit enter, and usually for the alias, when we want to know what the alias would look like, then we say alias and then mkx without any definition. Then if the alias is defined, then it will echo out what has been defined. So this is why we define it. Right? Also, by default, on the bash shell, we have a double L command. Right? So we would like to know what the double L command look like. We say alias ll, and that's what the double L command look like. So now we say ll in our directory. It will list the directory with those flags right here, those parameter, right? So let's say ll right here. Then we can see that just like before, we use the ls minus l. Now we have the ll defined by default first. So pre-expansion, we see that it's still white. It doesn't have the executable bit set right here, so we cannot execute it. Now we just define another alias. We call it mkx. So when we run it, now let's do the ll again to check. We see the color of the file name now changed to green, and the executable bit for the user is set here. Now we can execute the shell script, right? Just like before, we say slash dot and then tab, autocomplete the file name, and we done it. See here we say echo taoim, so the pre-expansion we expand it out to team. Okay, so that's how we can do saving and now typing. That is pre-expansion in bash scripting. Another example to do this one is let's create a file. Supply my file .txt and yet edit it and yet enter hello. Yet enter hello, okay, and we save it. Right. So now in the Linux shell, we can have a command cp for copy, and then my file we do on dot to recall the last argument of the previous command. The last argument of the previous command, which is the file name we want to copy, we would like to copy it to a similar file name. So we do it again. We recall it, but we call this one, we call it bk. For some reason, we want to change the myfile.txt, but before we want to change it, we say let's make a backup copy of that file. So let's do cp myfile.txt to myfile underscore bk.txt, and that's how we want to save a backup copy for now, right? A simple backup copy before we change the file. And when we do this, it will copy the file over, right? So for example, here, let's say copy. And now we say cat, that means that display the content of the file. Right? So the file we just copy on dot retrieve the last argument of the previous command and then display it. We can see that it is hello, just like the one that we enter here, right? So we got that file, and then now we got a copy command, we got the cat command to display the content of the file. Now we learn a new command called rm, and that means they remove the file, and we would say remove on dot, and that will go to remove the file that we want. Now let's say ll. We only have my file.text. We don't have the other file anymore. So when we say cat, if you go the up arrow back up, go back to the cat command, there's no file anymore, right? So now with the cb command and the brace expansion that we just learned, how do we use the brace expansion with our cb command? In here, rather than doing this, my file, right? And go in here and we use the brace expansion, comma underscore bk. So this is the same brace expansion that we learned before, but because the cb command only have a short and destination, only two parameters, so we have only two arguments here. This the empty and this one underscore bk. Right? Now we hit enter, and now we do ll. We can see that the file bk is also created, and with the brace expansion, we don't have to type a lot of text. We just modify the command just to have whatever the change, whatever the delta that we need to make the copy. And that is the benefit for the brace expansion. Not only for the bash scripting, but also for the command line, because this is a bash shell. Your script is a bash script. It runs by the bash interpreter. But here, it's like an interactive bash environment. The bash interpreter interact with us to execute the command in real life every time we hit the enter. So that's why whatever we learn in the bash scripting, it will also apply to here in the bash shell on the command line, that we use every day. So it benefits not just the scripting, but also the typing in every day. Okay, so now we have the file and we know how to copy it, right? And just to make sure that we got the right file, we do cat, right? And then we cat it just like before. We got the exact file, right? The same thing like before. Okay, so now let's go back to our example here. We just close this one out, and let's do echo 3.6 and also echo b.d, right? Now Control S to save it, and let's come back here, and we would do dot slash and tab. Even though we have three different files in this current directory right now, however, only one of them have the executable bit enabled. Only one of them can be executed. So when we hit tab, the bash shell know that there's only one that can be executable, so it picked that one first. It's very convenient. Then when we hit enter, we can see that before what temp, now we say 3, 4, 5, 6. The dot is the brace expansion for the sequence of number. And then following is the echo b.d. It also the expansion for the sequence of alphabet between the two endpoints inclusive. Right? So that the brace expansion. That is the end of our lab here for 4.3. I'll see you back in the lecture. Welcome to lecture 4.4, Arithmetic Expansion. In this lecture, we learn about arithmetic expansion in bash script. There are two ways for arithmetic expansion. Echo $square bracket 3 times 2 and echo double open parenthesis 3 times 2 close double parenthesis will yield the same result. Furthermore, we can assign the result of the arithmetic expansion like a 3 plus 5 into the variable sum with the following syntax: double open parenthesis, arithmetic expression, and then double close parentheses. The double parenthesis operator will also allow ternary operation. For example, if the text before the question mark yield a true result, use the value provided immediately after the question mark to store into result. Otherwise, if this text yield a false result, use the value after the red column here to store into the variable on the left side of the assignment. For example, if the value stored in variable vote is greater than 3, then store 1 into the variable bit, otherwise store 0 into the variable bit. Note that within the double parenthesis operator, the dollar is not required in front of the variable in order to retrieve the content stored in it. Next, the double parenthesis operator also allows increment and decrement operation. Here we see that with this syntax, the count variable can be added one to it. The double plus plus can be following the count variable. It could also precede the count variable. Likewise, in the decrement operation, the double minus can be following the count, just like here, or it can also be preceding the count up here. Within the double parenthesis operator like this, $sign is not required in front of the count. However, it also be okay to put a $sign in front of the count variable. Let us go to the lab and try out what we just learned in this lecture. See you there. Welcome to the lab. In this lab, we're going to try out some of arithmetic expansion that we just learned in the lecture. Okay, so here, before we do some practice, let's do some more shortcut that will be helpful every day. Okay, so here we have a lot of data on the screen, and we would like to start fresh. We would like to clear them up. So one of the commands to do it, time clear. Right? We can either time that clear, or we don't have to type it clear. We just hit the Control L. When we do Control L, the same thing with clear, but we don't need to time them. So Control L is only 2 keys. Clear is 5 keystrokes, right? So here we do Control L, right? Clear it, right? Now we do our ... to cd to the grandparent directory, ... right? Now we would like to make it a directory. Make the .p4.3 end. We make a new directory for lab. Oh, excuse me, it's gonna be a 4.4. Okay. Now we cd on dot to go to that directory, and we also go to our Sublime Text editor to close out the previous lab. Here, let's create a new file called arithmetic expansion. Simple arithmetic expansion. And as usual, we say /bin/bin/bash, and then just like in the lecture, we would like to try out the echo dollar square bracket 3 times 2. And for the win, we also want to try the echo dollar double parenthesis 3 times 2. Okay, so let's save the file and come to our terminal. We do the mkx like before. Now we do the /tab, and we see that both echo bring out 6. So the arithmetic expansion work for both the square bracket and double parentheses. Okay. So next thing is ternary operator. Ternary operator is very handy. It's just like if and else all together in one line. And we haven't learned about if and else structure yet to make the decision in our script, but here, because we are learning about the arithmetic expansion, we would like to discuss about the ternary operator to include it here. Okay, I go back in here into our text editor. We would do something like a volt. We define a variable volt like a voltage. We define it to be 2 voltage, and here we start into the variable volt, and then we would say bit equal. We would assign the value of the bit, okay, based on the voltage. We say volt greater than 3. If the voltage is greater than 3, then if that's true, we assign the value of 1 into the bit. Otherwise, it's a 0. Okay, so if volt is greater than 3, assign 1 into bit. Otherwise, assign 0. Okay, so this use this if the evaluation here you through use this. Otherwise, use this if the expression evaluated to phone. Alright, and after that we would bring out echo bit, and we try to display the value of the bit on the console, and let's see what we got here. Okay, we can use the up arrow to go back to the previous command and hit enter. Okay, so we see that the 2 6 is just like I did before. Now we have a third one, it's 0. It's 0 because the bit have 0 because the voltage is not greater than 3. So bit 0 is changed here, right? However, now if we change the volt to be what 4 and then save it. Now when we then go back to our terminal, we go back up with the up arrow, we hit enter. We got bit to have a value of 1 because the voltage is greater than 3. Okay. Moving on, we go back to the text editor. We enter something like sum equal dollar double parentheses 3 plus 5, and then we get print out the value stored in sum. Okay, this is the evaluation that we got up here, but before we print them out up here on line number 3, here line number 9, we store them into the variable, and this is how we store them, the evaluation, and then we print them out. Right, so go use the up arrow to go back up and hit enter. Now we got the a value at the end. Okay, so with that a value, we know that 3 plus 5 is 8. We store into the variable sum, and we print it out on the console. Now in the lecture, we also mentioned about increment and decrement. So let's try them out here. Count, let's say count equals 3, and we would say count blah blah, right? And we echo count. Okay, and after that we say count, we decrement, right? And echo count again. Right? And save the file. Now we go back here. We go back up. Let's hit enter. Oh, excuse me. Line number 17, echo have no dollar sign. Right? So we fixed it. We save it, and we come back to our terminal. We retrieve the previous command with the up arrow, and we hit enter. Now we can see that after the 8, we got a 4 and 3. The 4 came from the increment of 3. We increment to 4, we print it, and after that we decrement back down to 3, and we print it out. Okay, so now we show that how to increment the counter or decrement a counter using the arithmetic expansion. Okay, so that will be the end for our lab here. Let's take a short break, and I'll see you back in the lecture. Welcome to lecture 4-6, parameter expansion. Parameter expansion is used to receive parameter passed to a script or a function within a script. The usual format is the dollar, the brace, the position like a 1, 2, 3, and then the colon, and then the dash, and the dollar, the font, and close the brace. When the parameter is not presented, is not provided, then the default value here will be used instead. The next line shows an example where the first parameter is assigned to the name variable and there is no default parameter. So if the first parameter is not given to the script or not given to a function within a script, an empty string will be assigned to the name variable. In this example, if the first parameter to the script or to the function is missing, the string unknown will be assigned to name. Here, the string unknown is assigned to a variable capital default. Then that default variable is used here to retrieve the unknown string stored in it. I am doing this to show that here we can have a nested dollar inside the brace to retrieve the content of the variable. In other words, the default string to be used when the parameter is not given could be a direct text like this or could be indirectly via a variable. The point here is to show $sign could be nested inside the brace like this. This is the end for lecture 4.6. Let us go to the lab and try out what we just learned. See you there. Hello and welcome to the lab 4.6. In this lab, we are going to try out some of the parameter expansion that we just learned. Okay, so let's begin with our usual stuff. Let's go to the grandparent directory. Okay, I am going to make a typo in directory making so I can show you how to fix it using brace expansion. So I'm going to do make the minus p and I'm going to go 4.6.en. Instead of end, I'm going to say enc so that I make a typo mistake, right? Alright, so here I go cd and I go here. I say, oops, now I realize that I got a typo. So I cannot go in here. I would like to correct it. So I would say, I would change the letter C to the letter D, and then I go into the beginning of the command and I delete the two characters and I move to MV to move that one directory into a different directory, just like a rename of a directory using the brace expansion. Okay? And then now I can say cd and okay, so now I correct my typo using the brace expansion. It's just something that we need to practice and to get used to. Okay, so to do parameter expansion for this lab, we're going to sublime the parameter expansion .sh. Right? As usual, we do the standard /bin/bin/bash. Okay, and parameter expansion is usually to receive the parameter inside a function, inside a script. So here we have our script. So let's try to receive the parameter from within the script. So let's say opt equal $. I would take the first parameter that's sent to my script, and if I don't have it, then I would say colon dash, and I would use the word default value. Anything, but here I just say default value, or even if I say default space value without double quote. So now if my script is called with a parameter, then I would store that parameter into the op. Otherwise, take the literal default value and store into op, and after that I would print out the value of the op. Now Control S to save it, and here let's do out mkx. So we got it into the executable mode, And then now we call the script, and we got default value when no parameter is given. And if we pass anything like hello, right, then that value was accepted. So now we know how to accept argument for the script. So if there's no parameter provided, then a default value would be substituted. Okay, so that's it. That is the end for our lab here, and I will see you back in the lecture. Welcome to lecture 5.2, If Construct Introduction. When you automate your daily system tasks or engineering processes, the if construct is one of the key decision constructs to help you accomplish the automation task. Why? The reason is because in your automation, you need to read in the data on your system and then examine that data to see if a certain condition on the system has already happened or a certain event has already occurred in order for your script to take an automated action in response to that condition, to that event on your system. That is why the if construct is the key construct for your automation. There is only one if construct in bash scripting. However, to help make it easier to understand, I would like to present it as two different formats here on this slide. The first format is if that result is true, then do something until the end of the if. The semicolon here is required when then is on the same line with if, and if then is written on the next line following the if. The semicolon is optional. There can be one or more comments here in the body of the if construct. In the format number 2, if you call a function and that function returns 0, then do something until the end of the if. The reason I present two different formats here because these are usually the two formats that you would call the if, and I will present them to you in more detail in the next few lectures in this session. Let us continue with the next lecture. Welcome to lecture 5.7, Select Construct. In this lecture, we learn how to build a simple menu with the select construct. As shown on the slide, the menu is simply a choice of A, B, C, or quit. Each of these choices will be displayed separately as individual items. Then we use select to build a simple menu in the following syntax: select choice in $menu do. The semicolon here is required if do is written on the same line as select. If do is written on the next line, then this semicolon is not required. To pair up with the do is a done. On the script between the do and the done, here I consider the body of the select construct. The select construct will repeatedly go over the menu and send in the choice that the user pressed on the keyboard. This is the variable choice we pass. The select will store the text in the menu into the choice variable, and we use $choice to retrieve its content. If the content of the choice variable here is quit, then we echo by and we break out of the select construct because the select construct will continue to display the menu over and over again. There is no logic for the select to break. To break the select, it is your script responsibility to break out of the select construct. If the choice the user enter is not quit, and this condition will not happen, then the echo following the if construct will be executed. Then you will see the message you select $choice as menu item $reply. Here the $reply is a built-in variable that is used in connection with the select. The select will store the choice the user enter here in the reply. The text in the menu that you provide here will be stored in the choice variable here. However, the ID of the item, like a 1, 2, 3, 4, that ID is stored in a reply variable. To retrieve that content, we use $reply. To have a clear understanding of the select construct, let's go to the lab and try out what we just learned. See you there. Welcome to the lab for lecture 5.7, Select Construct. In this lab, we will build simple menu so that we can see how the select construct works. Let us begin with our exercise. Okay, so I'm going to edit a new file, basic select. And then I'm going to paste the script that I have for the exercise in here to save us some time. Okay, so as before, we go from the top down. We saw the regular subband directive to identify which byte interpreter to use. And then we have menu. This one very much similar to the one we learned in the lecture. So menu is A, B, C or quit. And then we build the select construct. Select choice in menu do. And this is the select body between do and done on line 5 and 15. Then it would in here, every time a user enters his choice, the variable choice will contain the actual text on the menu that we provide. And we look to see if the user entered quit. If he did, then we echo by and break out of the select construct. Otherwise, we will display this message. Note the reply as we learned in the lecture. This is a built-in variable for the select construct. Okay. Let's save this file and give it a try. Ctrl F to save the file and click on the terminal window on the right hand side. We go with our user mkx. Now we go /top. Okay, so we see that the menu we provide on line 3 is displayed here on 4 different lines with a number next to them. 1, 2, 3, 4, and the text for the menu came from the string that we provide in our script at line 3. The select will put the prompt right here. The pound question mark is the default prompt for the select. In the future lecture, I will show how we can change the prompt for the select. Now we enter 1 and the message you select A and the reply 1, just like on line 13 when we coded it. Likewise, if we enter 2, 3, the similar message would be printed. Now we just enter 4 here to quit. When the item 4 is selected, the text quit is entered into the variable choice, and our text on line 7 of the script here become true, and we echo a byte message and break our select construct. And that is for our exercise. Welcome to lecture 6.3, for in loop. The for in loop is to go through a sequence of elements, a list of items. For example, for I in 1, 2, 3, do, and then within the body of the for loop here, a symbol operation is to print out the content of the I. So it will print out 1, 2, 3 on 3 different lines here as I go through the list of items here. The brace expansion will also work in the for in loop to expand the range, the given range here, into a consecutive sequential list of items, right? So 1, 2, 3 will be expanded here, and then the I will also be printed 1, 2, 3, just like the for in loop before it. Another way to get the sequence of items for the for loop here is to use the unit command seq, and then we use the command substitution to get the sequence generated by the seq command to be used in this for in loop. So $, open parenthesis, seq3, close parenthesis, can be used here to get 1, 2, 3 as well. Another way to get the list of the item is to get not just the sequence command, just any item. For example, this command substitution get the output of the ls-1 command for I to go through. So whatever the list of the directory listing that return from this command substitution, I will go through that list, and then we print out the content of the loop control variable I here. To have more understanding about for in loop, let us go to the lab and try out what we just learned. Welcome to the lab 6.3 for in loop. As before, let's turn up our directory and prepare for the lab. Let's hit Ctrl L to clear the screen. And we also close out the lab of the previous lecture. Here we will create a new script with Sublime for in loop.sh. To save us some time, I'm going to paste in our new script. Okay, so here we will print out the I for the sequence explicitly 1, 2, 3. Okay, and we label A, we print I, and we print out an empty line with echo. Then we print out the sequence with the braced expansion. And then we also use the sequence command. This is the command substitution. We print it out, and seq will generate 1, 2, 3, and that output will be captured and printed here in the C. And again, we use the sequence command to print out 2, 3, and 4. Begin with 2, end it at 4. Okay, we start and end. And the one above it, sequence until the end. This is sequence start and end. And then also the next one, we have the same for loop, but we print out sequence start, step, and end. And finally, we print out directory listing of the current folder. Here we will save it with Ctrl S and come here, enable the executable privilege with mkx, and then now we run it. Oh, okay. So on line 28, there was mistake there, and we said line 28, and here line 28, it was supposed to be do only. Right, there was a typo there. So we save it, and now we run our script again with Ctrl P. Okay. So with A, we print out 1, 2, 3, and then with the B loop, we also print out 1, 2, 3 with the brace expansion. The sequence 1, 2, 3 in the C loop. The D loop 2, 3, 4 as expected, start and end, and the E loop 2, 5, 8. Okay, we start up to we print to 9, and the step is 3. So it add 3 to 2, that's 5, and then we add 3 to 8. But once reach 8, the next one is gonna be 11, and that's more than 9. So they stop printing. and the listing for loop F is display only one file in our current directory. The ls -1 only give one file name. And this is the end for the lab directory for in loop. I'll see you back in the lecture. Welcome to lecture 7.2, function definition and invocation. Bash function is a sequence of commands to be invoked, to be executed. Bash function have two different forms. Function and then a function name followed by open close parentheses and then the open brace and then close brace. Anything inside the open and close braces are considered the function body. In the second form, function doesn't have to have the keyword function preceding the function name. That function keyword could be omitted. And the second form of the function definition is more preferred. To invoke a function in Bash, you only need to call its function name, just like this example here. Let us study function argument in the next lecture. See you there. Welcome to lecture 7.3, function argument. In this lecture, you learn how to send argument to a function. Here, you call a function with one argument, separated by a space. You can call a function with multiple arguments, like the second example. First, second, and third. Note that the second argument must be enclosed in double quote like this because the second argument actually have a space among the data. So the complete sequence 1 space 2 space 3 is considered to be the second argument, and therefore they must be enclosed between double quote like this. Inside the function, you can receive the argument in this syntax $S or $*, both will yield a complete argument that's sent into a function. In this case, both A, 1, 2, 3, and B, the three arguments here, are printed on this line. Echo $S and echo $*. Both of these operators will yield a complete list of arguments that pass into the function show argument here. Then, to access the first positional parameter that pass into a function, we use the $1 or $2 to access their first and second positional parameter. Let's try out what we just learned in the lab. See you there. Welcome to the lab of lecture 7.3, function argument. In this lab, we are going to show how to pass the argument to a function. And as before, we are going to create our lab directory. Go to our drawing pattern directory, maker.p 7.3 end cd ont dot to go into the newly created directory. And we also close out the lab of the previous lecture. Here we are going to supply a new file called pass r to function h. Okay, so let me paste in the new script for our lab and we go over it. Usually when we read a script, we will read from a top-down direction, which means that we will read from the main script first before we go down to the function. So here we got the /n /bin/bash, then the function definition, right? And then this is the first time the function is called. The function show argument is by 3 different arguments. The first one is A, the second one is 1, 2, 3. And the reason they are enclosed in double quote is because they have space between them. And the third argument is B. Okay, so when we pass to them, this is how we receive the argument within the function. So we go into the function show argument, we take a look. It says the first line of pronoun is going to be $S, which means that on argument. The second line is $star. It also means pronoun on parameter, on position parameter. Okay, so that means that it print out everything that it receives. And then the third line, it print out the first argument. The fourth line, it print out the second argument. And the fifth line, it print out the first and second argument together on the same line. So, and then we print out an empty line after that, and we call the show argument again with just one parameter. Okay, let's save this file and go into the terminal window on the right, and like before, mkx, and then .star tab to get a full name of the script and hit enter. Okay, this is what we expect. Like we pass A123B, so we print out A123B in line 1 and 2 together. The line number 3 only print out the first argument, so that would be A only. Line number 4 print out the second argument only, so that's going to be 1, 2, 3. And finally, on the fifth line, it print out the first and second argument, and that is A, and then 1, 2, 3. We print out an empty line on line number 12. We echo to print out an empty line on the output console, right? And after that, we call the show argument again with just one parameter. And this time, on line 1, it print out, everything I got it just A. 2, the same way, everything I got is A. Third, the first argument is A. And 4, the second argument, because not given, so it's just like an empty string and nothing was printed. And finally, on the fifth, because the second argument was empty, it could only print out the first one, and in this case, only A. Alright, so what do we learn in this lab? This lab shows that the function in bash can accept multiple parameters separated by space after the function name. And if any particular argument have a space in them, they must be enclosed within double quote. Another point that we learned in this lab is that when the argument is not passed to the function, that argument is an empty string. But by default, it's going to be an empty string. And if we try to access the argument that is not given, is not passed into a function, we got an empty string. Okay? And we also learn how to get all of the parameter passed to the string. There are two different ways to receive them, $S and $star to receive all of them. And for any position parameter, we put the position like a 1 or 2 after the $sign to get them from their past in position. Okay? So this is the end for our 7-3 lab. I'll see you back in the lecture. In lecture 7-6, we learn about local variable inside function. Local variable is visible only inside a function where it is defined. In this example, we have a file level variable. This has a scope for the entire file. Any function, any script in the file, we have access to this variable myCounter in green. In the function show local counter, we have another myCounter, but this myCounter is declared as local, and when we assign the 3 into myCounter, we print it out here. This one will show 3 as a local variable. This is the function definition. Outside of the function, when we invoke the function show local counter, the value 3 will be printed when the function is called. And after that, we'll print out the file level variable myCounter, green right here. And thanks to the local keyword here, the output will be 3 for the local variable and will be 5 and remain 5 for the green myCounter. If somehow, for some reason, if we take this local keyword out, This assignment here inside the function will change the file level my counter in green. So the 3 assigned to the red my counter will also change the content of the green my counter outside of the function. So the local keyword here is very important to keep this local variable private. Any change to this variable will not have an effect to another variable whose name is the same outside of the function. And it is highly recommended that we have local variable as much as possible in our function. Let us go to the lab and try out what we just learned. See you there. Welcome to the lab for lecture 7.6, local variable inside function. As before, let us clear out the current directory and create a new one for our lab. Go to grandparent directory, and then we do make dir-p to create multiple directory and subdirectory. Make dir-p to create multiple subdirectory. And then we cd into that newly created directory with on dot. Alright, now we close out the lab of the previous lecture and we create a new lab for this lecture. We will say sublime local variable .sh. Here I will paste in a script for our lab. Okay, so let's analyze what we have here. So we go from top down. We got the subaim directive and we have a file level variable my counter and we assign the value of 5 to it. Then we have a function. So now we're not reading the function, we go to the closing the function. And then we see that, oh, now that function is being called. There's some script here to call that function. Okay, so we go back to the function, see what it does. So this local function create a local variable my counter. That my counter is also the same with the file level counter. However, it got the keyword local in front of it to make it local to that function only. Line 7, the comment, and we're not talking about that line yet at this time. And then on line 8, we print out the local variable at line 8. Okay, and then we come back out here after line 11, we print out file level my counter at line 13. Right? So in this lab, we print out two different variables, one at the file level scope and the other one local in the function scope. Alright, let's save this file. Click on the terminal window on the right side and our usual command mkx and then /top. Okay, so we see that the local variable printed out on line number 8 print the local variable 3 and the file level variable continue to be 5. So we know that when we have the word local in front of a variable, like we define on line number 6, we actually define the local scope of this variable to protect it from having side effect. So anything here, even though we have the same variable name with another one outside of the function, but our modification of that variable inside the function does not affect the value of the file level variable. Okay, this is local scope to the function only. Now, let us comment out line number 6 and enable line number 7. So what it does at number 7 now is that we define variable my counter, but we omit the keyword local to indicate that we don't intend to have this one to be a local variable. We would like to modify the file level variable so we don't have the keyword local in front of it. So let's save that file and go to our terminal window, hit Ctrl B to go back up and hit enter. Now the local variable inside is 3, but the file level outside the function is also 3. it shows that without the keyword local, we can really change the file level variable. When you define a local variable inside a function, make sure that they have the keyword local in front of them to protect them from having side effect to other file level variable outside of the function. Alright, this is the end of the lab for lecture 7.6. I'll see you back in the next lecture. Welcome to lecture 7.8, exit code of a function. Bash function can return an exit code up to a value up to 55. Beyond that, it's gonna be a modular up to 56. So from 0 to 255, and anything beyond that, it's a modular up to 56. So we can only have the value from 0 to 255 for the exit code of any function in Bash. And here I present a simple function that does nothing but return 0. In Bash, a return code of 0 is used to indicate a successful result. Otherwise, it would be a non-zero return code. And I show two different ways to check for the return code. First, we call the function, and then by default, Bash will store the return code of a function inside the $question mark. We then use the return code or the exit code of the function that already stored in this default variable to test again 0 to see if the function operation was successful or not. Here, if the exit code not equal 0, then it's an error and we exit. The other way to check for the return code of a function is to use this idiom. If not my function, then echo error, exit, and if construct, right? So the return code checking again non-zero is being performed by the exclamation point here. So the exclamation point right here in green is equivalent to the condition right here in green. They both are the same. This one say $question mark not equal 0. And this one, you call the function and you put the exclamation point right in front of the function name to check for its return code in the if construct like this. The green expression right here and the green exclamation point right here are the same. The red color, the double parenthesis right here, the ampersand, the brace here and the closing brace, everything in red are equivalent to the if construct in red here. If, then, fi. So they are equivalent. Let us now go to the lab and try out what we just learned. See you there. Welcome to the lab for lecture 7.8, exit code of function. In this lab, we are going to try out some of the exit code and the technique to check for exit code that we just learned from the lecture to have a clear understanding about exit code of a function. As before, we are going to create new directory for our lab. We are going to grandparent directory, make multiple subdirectory. CD into that directory. And we also need to close out the lab of the previous lecture. Now we create a new script for this lab. Sublime exit code on sh. Just like before, let me paste in the script for our lab here. Okay, so from the top down, we got my function. Okay, so now my function is called. So what my function does, it does nothing there but return whatever the value that passed to it. So when we want my function to return a particular value, for each exit code, we just pass it in from the function invocation. Okay, so on line 8, we call the function, we pass in the parameter 0, we want it to return 0, as if no error, right? On line 9, we check the return code. The return code of the function by default is stored in $sign ? In bash. Okay, so we check for the return code against 0. So if it is not 0, it is error. Again, if the return code stored in the $, is not 0, it is an error, and we'll print the error message. The second way to check for return code, if we call a function in method 2 on line 11 here, make sure that we have the exclamation point here. So if exclamation point my function 0, then echo error, which means that if my function returns something not 0, then it's an error. Right? So this is how we call it. This is a function calling idiom that we need to remember. Okay? And likewise, in line 14, we call the same function again. Now we wanted to return a non-zero to indicate that it is an error exit code. And again, we did the same check on line 15, just like that check on line number 9 to see the error message being printed this time. And also on line 17, we make the same calling, actually a similar calling to line 11, except that this time we pass in the 1f parameter to indicate that now we would like the function to return a non-zero exit code so that we can print out the error message on line number 4. Right? So let's save this script and run it through and get an understanding of the script so far until line 17. Okay, let's save it. Go to our terminal section on the right side and run mkx to enable the executable bit for the user, and then run /tab to get the script name. Okay, so let's ignore number 5 and 6 right now. Let's look at number 3 and 4. Okay, so when we call the function line number 8, we pass in a 0, it returns a 0, and on line number 9 we check for error because the function returned 0 as we wanted it to be. There is no error, the message never got printed. Same thing with line number 11. To indicate that number 11 and number 9, the code are the same. You also check for the return code of the function, and the function returns 0, so no error. And as a result, the error message at 1 and 2 were never printed. Now at line number 14, we call the function again, and we check on line 15. The check on line 15 indicates that it is an error because the function does indeed return 1, and that 1 not equal 0, so the error message at line 3 was printed as expected. The same thing at line number 17, the error message was printed for line number 4. So at this point we know that number 9 and number 11 working the same, and number 15 and number 17 are working the same. So we confirm that they are working for both non-error and error scenario, right? Because of that, we know how to use them in the future. We know how to check for the exit code from a function. On line 20, we call a function again when we give it 255, and we try to prove that 255 is the maximum exit code a function can return. So after that, we print out the exit code that's stored in the $? Here on line number 5. Right? We can again my function with the parameter 257, and we would like to prove that the exit code is actually whatever the exit code modulo 256. That means that the exit code is the remainder of whatever divided by 256, right? It's the modulo of 256. This operation is called modulo. That means that the remainder of the division from the exit code. Okay, and we also printed out the exit code for 257 here. And go back to the terminal on the right side, we see that line number 5, my friend print 255, my friend 255 return 255, exactly as we expected. However, unlike 6, my from 257 returns 1. That is the remainder of 257 divided by 256. Right? So we know that it confirmed that whatever the exit code modular by 256 is what we got for the exit code in the $sign question mark. Okay, so from this lab, we now know how to check for the exit code from a function. And we also know that the exit code can only reach up to 255. Beyond that, it is a modular up to 56. So this is the end for our lab of the lecture 7-8. I will see you back in the next lecture. Welcome to Section 8, Regular Expression. Regular expression, sometimes pronounced reg x, is used to search for patterns in a string. There are different types of meta-character in regular expression to have a specific meaning. We will learn the definition here and how they operate. Then we will try them out later in the lab. The anchor in regular expression are used to find patterns at a specific location in a string. Caret is used to indicate that you want to find something at the beginning of a new line or right after a new line character of the previous line. The $sign is used to indicate you want to find something at the end of the line or right before the new line character. The slash left bracket is used to indicate you want to find something at the beginning of the word. And similarly, slash right bracket is used to find something at the end of the word. Next, the characters are used to express the text to find. And the dot is used as a placeholder to match anything, to match any character at that place. Moving on is the grouper that are used to group one or more expressions together. There are two different types of grouper. The first one is both group and capture the expression and then label that expression with numbered label for back reference later. The second type of grouper consists of open parenthesis, question mark, colon, and then the expression in place of the dot here, and then close parenthesis. This is the non-capturing grouper, which means that you can group them together. You can place quantifier on them. You can apply regular expression meta character on them, but you cannot refer back to them later. And next is the back reference, which is the backslash and then a number to indicate the entity group that was captured with the first type of grouper. So you can refer back to that expression without rewrite that expression again. Quantifier meta character in regular expression are used to specify the number of characters or groups to find in a string. The asterisk, when it follows a character or a group, is used to indicate that you want to match 0 or more of the character or groups before it. The question mark is used to indicate that you want to match 0 or 1 of the character or group before it. The plus sign is used to indicate that you want to match 1 or more of the character or group before it. Similarly, and between braces is used to indicate the exact match of n time of the character or group before it. And comma between braces is used to indicate that you want to match at least n time of the character or group before it. N, M between brackets is used to indicate that you want to match at least N times, but no more than M times of the character or groups before it. Next, the alternation metacharacter. The vertical bar is used to indicate the OR operator to match one of the expression. When a match occurred either on the left side or the right side of the vertical bar, is considered a match. Character class is used to indicate that you want the current character in the string to match any character in the set. For example, when you specify ABC between brackets like this, you want to indicate that if the current character in the string is A or B or C, then you would consider that as a match. Another way to write character class ABC in square bracket like this is to have the non-capturing grouper, parenthesis, question mark, colon, A or B or C, close parentheses. But this is a much more common way to write a character class than using the non-capturing grouper like this. You can also have a range in character class expression. Here you indicate that if anything in the range from A to Z in the alphabet, it would be a match. And here you indicate that if the current character is a digit from 0 to 9, a uppercase letter from A to Z, or a lowercase letter from A to Z, any of those characters appear at the current location in the string, you would consider a match. Next is the negate. You use the caret inside the character class like this. The caret must be the first character follow the open bracket like this to negate the character class, which means that you don't want to match A or B at that location. Anything different than A and B is okay. You would say that, okay, it's a match. But if that character is A or B, then that's not a match. You don't consider that as a match to the pattern you're looking for in the string. In other words, you don't want the regular expression engine to match that current character to your expression. You would exclude it. You would exclude that current character as a match in your expression. You won't accept it. Next, you can use /s to indicate that you want space. Space here is white space, which means that you want it to match a space or a tab. So if you say /s a, you want to say that you want to match the A follow a space or follow a type character. /S is the opposite to indicate that you don't want space. /D is to make a digit from 0 to 9, or /D to indicate that you don't want to match a digit. /W to indicate that you want to match a word, which means that you want to match anything between two different spaces, two different /s's. And capital W here is to mean you don't want to match a word. Next is the POSIX character class. This is the POSIX version of the character class, which means that you can use double bracket, colon, alpha, colon, double bracket to indicate that you want to match any character at that position, either capital A or with a capital G, A to Z, any character of that position would be considered a match. Similarly, double bracket, colon, digit, colon, double bracket is used to indicate that you want to make a digit at that position. So far for the last few lectures, all of these are definitions and they may sound confusing. So let us learn how to use regular expression to search for patterns in the text, and then we go to the lab and try them out. See you in the next lecture. Welcome to Session 9, String. Many daily system tasks focus on the processing of string. For example, analyzing log file for error, checking system for operational status in order to take automatic action. So operations on string are very important in automating daily tasks, in automating your engineering process in order to boost productivity. A lot of things that can be automated by just looking at the data that you receive and take appropriate action automatically. So in this session, we learn standard string operation in Bash, and we also learn to develop a few custom string operation that Bash does not offer yet, and we will develop them in our lab. In particular, we will develop the index of, the last index of, and the chain last substring in the lab. Welcome to section 10, Array. Bash has one-dimensional array to contain elements. There are two types of array, indexes and associative. Index array use zero-based numerical indexes, and the indexes don't have to be consecutive. Associative array use string key for indexes. Associative array work just like a dictionary where the values are looked up via key. Welcome to lecture 11.2, redirecting input and output. Here we learn to read data into the variable line with the command read. And where do we read it from? We read it from a file, myfile.txt. This is where the data is stored, and we read from that file one line at a time and store each line into a variable line. Here we redirect the output. When we echo before, we display the message on the console, but now we don't want to display the message on the console. We would like to write this message, hello, how are you? And we write it to the file called myfile.txt, and here is how we redirect the output from the console to myfile.txt. When we use this syntax to redirect nothing to the file, it means that we would like to truncate that file. You got to be careful when you use this command because the data and the symbol that's on .txt will be gone. The file size will become 0 and the content is truncated. All data will be lost. Please use with care. Finally, how do we append the output to already existing file? We do echo. Now, we don't want it to echo out on the console, but we want it to be redirected to the end of a file. We use the double redirection here to append this message to the end of my file.txt. This is the end of lecture 11-2. I will see you in the next lecture. Welcome to lecture 11-3, merging standard error with standard output. Here, we learn how to write to standard error and merging standard error to standard output. So far in the course, we always echo to the screen, to the console, and when we echo the console like that, we write it to the standard out. However, on the console, there are two different output streams. The first one is standard out, and the second one is standard error. Even though they may show up on your monitor, but they actually confirm two different output streams. So, in order to write to the standard error on the console, your echo command must have this symbol at the end. To redirect, 1 stands for a standard output, into 2 stands for a standard error. And that means that this message will be echoed to standard error because you indicate that you want the standard output to be redirected to standard error. This is another way to indicate the same thing, to echo the message onto the standard error. Now, how do we merge standard error to standard output so that other program utility, when they try to capture the standard output, they will also capture from the standard error. When the standard output and standard error are separated, the utility that capture from the standard output will only capture from the standard output, or another utility, when it capture from the standard error, it will only capture from standard error. Now, we want the same utility to capture both standard output and standard error together. And that means we need to merge the standard error into the standard output in order for that third utility to capture both the standard output and standard error together. And there are 4 different ways to express that intention. Here in method 1, method 2, method 3, and method 4. And I list all of them out for your reference. However, the method 4 is the preferred one. Ampersand redirect to a destination, right? The destination could be a file or could be a device. In this case, we redirect the standard error to the standard output and then throw all the data away when we redirect them to the def node. It means that the ampersand redirect will merge standard error and standard output together and then send to def node to throw those data away. Why? The reason because in this particular example, we try to grab for the data the HTTP keyword from the access side.log. Grep will usually print out either the output or the error message. And we don't care about that output, and we don't care about the error message either. All we care about if grep return 0 or not. If grep return 0, we know that HTTP has been found in this log file. And then we echo out the message file, or we take appropriate action when the HTTP keyword is found in this particular log file, right? If grep for some reason return a non-zero for either HTTP not found or for any other reason or any other error, we don't care. We only care if it returns 0 and is successful when we take a particular action for that scenario. And that particular action in this case, it just simply echo a message file. But it could be any other action taken in your script to do the daily task that you need to do. Or any engineering process or anything that needs to be done under that condition can be expressed here. Okay, and that is the end for lecture 11.3. Let's take a short break here, and I will see you in the next lecture. Welcome to lecture 15.2, Useful Built-in. In this lecture, I would like to introduce a few useful built-in that you will most likely encounter when you develop your bash script for the enterprise. The first one is the double dollar sign. The double dollar sign is a special built-in variable used to store the process ID of your running script. Your running script is a process running on a system. Every running process on the system will have a process ID. Bash interpreter store the process ID of your running script in the special built-in variable $sign, and you need another $sign to retrieve it. So that makes it a double $sign to retrieve the process ID of your running script. The second built-in variable I would like to introduce is the bash PID. You use the $bash PID to retrieve the process ID of the subshell. Every time you run the command in the subshell within the parentheses in bash, that subshell will have a different process ID. So just in case you need a different log for your subshell, you can use the $bash PID to retrieve the process ID for that subshell. Bash PID will store different PID for different subshell, whereas double sign will retrieve the PID of your running process even if you call it inside a subshell. It's still the same process ID. One way to utilize the process ID is to generate the unique log file name for your script. The reason is because when you develop your automation script at the enterprise level, you need to log the error, you need to log the warning, so you can review those errors and warning later. Because most of the time, your script will be running unattended based on a particular system condition, based on a certain time of the day. And most of the time, you will not be there to watch your script running. So you need a log file for review later. One way to create a unique log file name is to use the date command to generate date and time along with the project ID as presented here. And the date command with this format will generate a file name like this: year, month, day, T for time, hour, minute, second, PID. This is your running script PID. And this is a fairly unique name based on the time when your script is running. Coupled with the process PID. So this will help you avoid collision of the log file name. There are two more useful built-in I would like to introduce. They are PWD and old PWD. The old PWD built-in is used to store the previous working directory. That is, it stores the directory where you were before you change to the current working directory. The pwd stores your current working directory. One way to use those special built-in variables is to assign the current working directory to a destination variable and then assign the previously working directory to another variable. Then you copy the file, keeping the permission from the previous working directory to the currently working directory. There is a very useful command cd space dash. This command will help you toggle between the current working directory and the previously working directory. So in case you are here in this currently working directory, but you need to quickly go back to where you were before, you can cd space dash and you go back there. And after that, you want to go back to where you were a moment ago, then cd space dash again. It will toggle you back to the directory that you were previously in. So it will only toggle back and forth between the PWD and the older PWD. This is the end for the lecture 15.2. I will see you in the next lecture. Welcome to lecture 15.5, How to Get Help in a Bash Shell. Bash has been around for many years. As a result, Bash have so many different commands. Every one of us will need to look for help info from time to time. So, how do we get help in a Bash shell? First, we try with a time command, like in this example, type and eval. When the command in question is a built-in shell command indicated by type, the next command to type is help and then eval. In this case, to get a detailed description of the built-in shell command. If the command in question is an alias, the type command will show the definition of that alias. And also, if the command in question is a user-defined bash function, the type command will show that function body, function definition, as we already saw in the past when we were working on the backup command. And there is a limitation for the time command. Beyond those, the time command does not show much helpful info anymore. After that, we need to try the file command. In this case, we need to see if the /bin/bash is an executable or not. If it is an executable, then we will try the man from the manual page of the command in question. If the file command detects that the command in question is an ASCII file, then we can open that ASCII file to review. If the file command indicates that the command in question is a shell script, we can open that shell script for review. Let us try the help command we learned in this lecture in the lab. See you there. Welcome to the lab for lecture 15.5, How to Get Help in a Bash Shell. As we learned in the lecture, we can get some help within the Bash shell. Let's try it here. First of all, type eval as we learned in the lecture, and it shows that eval is a built-in command. The next command we type to get help is eval. This is a detailed description of the eval built-in command. Next, we can try type ll, and we know that ll is our familiar alias that we have been using in the past, so we try it out to verify our command. Now it shows that the type command shows the definition of the alias here. To verify that, we type alias ll, and here this is the definition here for the alias, and it confirm with the type command. Okay. Now, what if we do a type on a user-defined bash function? Right now, we don't have any function yet, so let us quickly create a user-defined bash function within this shell. Okay, and here we say echo hi. Now, we do type, and now with a user-defined function like this, the function definition is displayed as we already saw in the past when we learned the backup command. And no further help is needed at this point. Once we see the function definition here, we know what it does. That is the three category of command that the type command will work well. However, we need to type an executable command to see the limitation of the type command. Now, type. Actually, let me have a space here. Okay, and let's say type, and then bash. Here, it say /bin bash. Okay, that's not much help. So we will try, and this one came from here. Okay, now we say file /bin/bash, and it shows that bash is a 64-bit executable. Okay, and with that we will try man bash to get the manual page for the bash command. This is what you would expect to see from a manual page. You can move up and down to view the manual page with the mouse up and down. Okay, with the space bar for forward paging, or with the B for backward paging. Here we type Q to quit. Okay, and so how about shell script? Here I already created a couple script files in this directory. Let's see what they are. Okay, so those are the familiar scripts that we created in the past on lecture 14.1. Okay, so let us try the file command. Let us try the time command on the util.bash. Okay, it's not found because we need to enter the path for the time to find the file, the command. Okay, so this is not much helpful information here. Okay, so we need to try the file command. Now we go back with Control P and then Control A and then on D to delete the word under the cursor and type file. Hit enter. It says util.bash is an ASCII text. Okay, and we knew that this is the file that we got in the past, and Control A on D again, and then sublime just to view the content, right? So because this one have the bash function, but the system does not know that. Only us know that per convention we name a util.bash. We knew that this is a bash utility, a bash function, but the system doesn't know that convention. It is our user-defined convention. So we know that the system tells us it is an ASCII text, and we need to come in and view that ASCII text to confirm that it is indeed a bash function to have all the bash script. Now, let us try the other file in here. We only try this file in the current directory. Let's try this file. Okay? So, let's hit an enter key to get an empty line, and then issue the type command dot slash path. Okay, here once again the type command does not show much information from here, right? So based on this, we need to go back and try out the command in question, the file in question with the file command. A on the and then file. This time, the file command shows something different. It's a bond shell script architect executable. Why? Let's take a look inside this function. Again, Control P for previous command, Control A for beginning of the line, and then on D to delete the word under the cursor, and then sublime. And we can see that how the file command could determine that this is a bond shell script. It is because of the /bin /bash directory in line number 1 here. And that helps the file command identify the file in question is a shell script. Okay? And from here, we can edit the file and review its function, its content. There is no further help needed because the script should contain all of the information needed for that particular command. Okay, and this is the end for the lab 15.5. See you back in the lecture. Welcome to lecture 15.7, an unofficial script anatomy. Here in the lecture, I would like to present a sample script anatomy. In here, I suggest that we should start with the /bin /bash for all of the script that you're gonna write. You have to make sure that if your script is running from any other particular shell, they will be redirected to run under the bash interpreter. The system will load the bash interpreter to run your script here. Then you divide your script into multiple sections, and one of them here should be the variable section, right? And this is the variable section. It could be followed with the include section. You can include the script from other library, from other include directory up here, and then the variable section for your script is here. Here you can export global environment variable so that any other script that you call later will have access to this data in your script. And the var1 here is the variable that on the function in your script right here, in this particular script, will have access to. And then follow with that is the function section. The function section is all about function. They are on function. And you keep everything in the function. The reason for that is because inside the function you have local variable. The locality will help you later when you debug the problem so that you don't have a side effect somewhere else. Okay, and the main here is the main function that will call other function to pull from the task. And finally, the only script that you call is on the bottom of the script where you bootstrap the main function and pass on the parameter that you receive for your script into this main, right? And the main will be operating as a local function here in your script. Okay, so let us go to the lab, and I can present to you a more detailed app skeleton script that you can use it for any of the bash script you develop in the future to automate your system tasks, to automate your engineering process. You are free to use it so that you won't have to start from scratch. Okay, let's go to the lab and I can present that skeleton script to you. See you there.